Hello everyone, welcome to this video in the continuing series of seasonal inventory management. So in the last video we looked at finding the optimal cycle service level when you have a discrete distribution. Now we look at a scenario where the distributions are continuous. So if the distribution is continuous, the idea is similar. We will still calculate um, the cycle service level as we usually do. CU divided by CU plus CO, we'll calculate that. And then we will put it into the continuous distribution, whatever continuous distribution it is. And then we can calculate the expected profit. And we can also calculate things like what is the expected amount of overstock, what is the expected amount of understock, and all of that. So we'll be able to calculate all of those values, and let's let's calculate those things. So the one continuous distribution that we will talk about specifically is the normal distribution. Now the formulas that are given in the textbook are for the older versions of Excel, so we just have to update the formulas a little bit. Instead of saying norm INV inverse or normal inverse, we're going to say norm dot INV. So it's only simple changes, nothing very complicated. So what we'll do is let's take a concrete example, and we'll begin with that. So let's take this example where let's look at a similar idea. So let's say that you're making parkas, you're selling the parkas for, you're making jackets, you're selling the jackets for $250. It costs you $100 to manufacture the jacket. At the end of the season, you can salvage them for around $80. So disposal value is 85, holding cost is 5, so the salvage value is $80, right? Now this time we'll assume that demand follows a normal distribution with an average demand of 350 and a standard deviation of 100. So on an average it's 350, so it can be less or more, and the standard deviation of that variance the standard deviation of that of demand is 100, right? So what we'll do is we calculate the cycle service level the same way. So first we'll calculate the cost of understocking. What is the cost of having one fewer jacket? So that's the difference between, that's the potential profit that you could have made, which is $150. What's the cost of overstocking? Cost of overstocking is the difference between the cost of the item and the salvage value. So salvage value is 80, so the cost is 20, which means that if you had one extra jacket left over at the end of the season, it costs you $820 because you can only sell it for $80, even though it costs you $100 to make it. So you'll recover only 20. So it'll cost you $20 to actually have had that one extra item. So that's the cost of overstocking. With that, we can calculate the cycle service level as 150 divided by 150 plus 20, which will be 0.88. Now using that, we will calculate the optimal order quantity. Now the way we do that is because we assume that demand follows a normal distribution, we have to figure out, well, if I order 400, if I order how many items should I order so that my cycle service level becomes 88%. So 88% is a probability that you'll be able to satisfy customer demand. So with that probability, we will calculate back using the mean and standard deviation the value of optimal order quantity. And that will turn out to be around 400, not around, will be turn out to be 468 items, right? So let's do that first. So what I'm going to do is I'm going to look at normal distribution, discrete normal demand distribution, right? So let's look at the values that we have. So the sales price is P. He's selling it for $250. The cost is C. So cost is $150, right? Cost is 100. I'm sorry, cost is 100. Salvage value is 80. Now the average demand and standard deviation of demand, which is sigma. Average demand and standard deviation of demand. So average demand is 350, standard deviation is 100. Right? And then with this we can calculate this cost of understocking. Right? So cost of understocking. So if you have one fewer item, which means that you lost out on a sale, cost of overstocking will be the loss when you have to salvage it. So that I can calculate the cycle service level, the optimal cycle service level, which will be CU divided by CU plus CO. So let's just make it two decimal places. So once I have the optimal cycle service level, I can calculate the optimal order quantity. This we calculate as norm inverse of the normal distribution. So norm dot INV, the probability, so that's the cycle service level, comma, the mean, which is 350, comma, standard deviation, which is 100. Now, obviously, the order quantity has to be, because we're talking about jackets, it has to be a whole number. So we have a couple of options here. We can either round this up or we can round this down. Now, it looks like the textbook has rounded it down always. So even though the value is more than 0.68, I don't know why. So I'm just going to round this. So when I write this formula, I'll just have a round function. So I want to round this to 0 digits. So 469 it says. So you know what? Let's just round it down. So you can always round down. So what this does is always round down. So 468. So it looks like the textbook is rounded down. So there are multiple reasons why the textbook has 468, because they restricted this to 2 decimals. So they're only using 2 decimals. That's why we might end up at 468. So let's actually not do that. Let's just do a regular round. Let's not do a round down. Let's do a regular round. So 469. So 468, 469, it's all not going to matter that much, right? So that's your optimal order quantity. So apart from the optimal order quantity, you also want to find out what the expected profit is. On the expected profit. And I also want to calculate the expected amount of expected overstock and expected understock. So how many items do you expect to overstock by and how many items do you expect to understock by? But let's begin with the profit, right? So when you're doing, so once you calculate the optimal order quantity, the expected profits, this is the formula for the expected profit. It's pretty involved. So let's go through this. Okay, I'm gonna need the formulas here. So yeah, it should be good enough. I have the formulas right here. That's my formula for the expected profit. So let's put that in. So it's P minus S right, times mu. So mu is the average demand, right? Times. Now here they say non-dist and they do ones and zeros and all of that. So I'm going to do, so this is the standard normal distribution, right? So this 0 means that the average value is 0, standard deviation 1. So this is standard normal distribution. And the final one means that this is cumulative. So we are looking at the cumulative distribution. So I'm going to collapse all of the zeros and the 1. I'm going to call it norm.s.dist. So when I do s in the middle, it means that it's a standard normal distribution. And the z value is this value, the O minus mu over sigma, which is the optimal order quantity minus mu divided by sigma, right? So that's my optimal order quantity, O minus mu divided by sigma. That's my, that's my z value, comma. Now it's asking whether you want it to be cumulative or not. So if you say true, so true is the same as saying 1. So if you say true, it means that you're talking about cumulative distribution. So that's just the first part of the expected profit. Now let's write the second part. Minus, you have P minus S, times sigma this time. So last time we did times mu, now we are doing times sigma, right? Times again. So this time it's norm dot standard normal distribution again, mean is 0, standard deviation is 1. But this time we're not looking at the cumulative distribution. So we will say again times norm dot s dot dist. But this time the z value is the same. It's order quantity minus mean divided by the standard deviation. So that part is the same. But this time it is not, it is 0. It is not a cumulative distribution. That's the second piece, right? Minus Q times C minus S Q times C minus S times, this time it's a normal distribution, but with the mean and standard deviation for demand. So we'll do norm dot dist only, not the standard normal distribution, but any old regular normal distribution with a mean of 460. So add 469 with a mean of 350 and a standard deviation of 100. So mean is mu, standard deviation is sigma, comma 1, which means that it is a cumulative distribution function. And finally, plus Q times P minus C times 1 minus this distribution. So it will be 1 minus norm dot dist, 1 minus norm dot dist of Q, comma mean, comma standard deviation, comma, is this 1 or 0? Okay, it says 1 here, so let me say true for the time being, but I have a feeling that should not be true. Okay, so this whole thing is this formula here, right? Let me quickly check this formula in the textbook just to be sure. Expected profit O star P minus C. Yeah, it is still 1. Okay, good. Okay, so that's the expected profit value. So what is the number that they got? They got 49,146. So 49,146, that's exactly what we got. So now let's calculate the expected number of units that you overstock by and the expected number of units you understock by. So the formulas are here. They're it's going to take a couple of seconds. So I'm going to quickly type in the formulas, which will be Q minus, so Q minus mu times norm. So this is the standard normal distribution. Mean is 0, standard deviation is 1. So norm dot s dot dist of again minus mu divided by sigma, right? Comma, it's again true. It is a cumulative distribution. That's the first piece here, right? Plus sigma times norm dot s dot dist again, so it's standard normal distribution of again O minus mu over sigma O minus mu over sigma comma false, right? So that's the second half of that, right? There you go, that's the expected overstock. What I'm going to do is I'm going to put a round function around it. You know what? It's not. It's the expected value, but I will fix that in a second. No. Finally, expected understock. So again, so this is the formula now. This time it's mu minus O will be mu minus the optimum order quantity times 1 minus norm dot s dot dist, right? So it is norm dot s dot dist, mean is standard, 0 standard deviation is 1. Norm dot s dot dist of O minus mu divided by sigma comma true plus sigma times norm dot s dot dist of again q minus mean divided by standard deviation plus sigma times divided by standard deviation, right? So yeah, divided by standard deviation, and then that's it. So this time it's false. Not looking at a cumulative distribution. That's that. I forgot parentheses. Something is amiss. You got mu minus, where is it? Mu minus O times 1 minus norm dot s dot is B14 minus B6 divided by B7. That's true, comma true. 1 minus, right, so that and then that. Okay, there you go. Now that makes a lot more sense, right? So with this, they got 108. They're looking at optimal order quantity of 450, so they got 108 and 8, but we are looking at optimal order quantity of 469, so we'll get 125 and 5. So those are the formulas for the optimal order quantities and expected amount of overstock, expected amount of understock. Few things, because these values you want them to be integer values, you have a couple of ideas. You can either write round functions, or what I tend to do is I just tend not to show the decimals and say that the expected overstock is 125 items, expected understock is 5 items. This is a dollar value. All of these are dollar values. These are dollar values too. That's a percentage. I'm going to leave that here. That's the optimal order quantity, and there you go. And that's the idea here. And that's what you do when you have a normal demand distribution. So again, this video is too long, so I'm going to end this video here. There'll be one more video this week where we'll talk about what happens in the when you have quantity discount. So that's the final thing that we'll talk about this week. All right.